All right, so we're now moving on to the second section in chapter 17, and that is going to be our section B, our graphs of quadratic functions. This section is actually going to be broken up into multiple videos. The first video in this one, we're just going to go into the basic presentation of it, and then we'll learn how to graph one equation in this, or one function. And then in class afterwards, we'll talk about some more things before we get into the second video. So I'm going to try and keep this one pretty short. But there are going to be multiple videos for this, and this is going to take multiple days. So the graphs of all quadratic functions are parabolas. And parabolas are U-shaped graphs, all right? So it's U-shapes that can open up or they can open down, but they are U-shaped graphs. The parabola is one of the conic sections, and the conic sections are curves which can be attained by cutting a cone with a plane. And here we have a cone, and we're intersecting it. If you see this green shaded region, that we're intersecting it with a plane, and when we intersect it, you see we get this U shape or a parabola. So that is how we obtain our parabola. Parabola is actually comes from the Greek word for thrown, because when an object is thrown, it forms it makes a parabolic arc. So, for instance, anytime you ever throw a stone, your stone is going to create a parabola from when you throw it to when it lands. Or if you kick a soccer ball, whether you kick it high in the air or if you kick it low, it's still going to form a parabola. It's just one might be wider than the other. So parabolas are actually all around you, and you just might never have noticed them. They're actually, parabolas are part of mirrors in cars' headlights. They actually are part of certain bridges where they might have a parabola to help support the weight. So parabolas are all around us, whether we're throwing something, kicking something, or in the structure of buildings. It's actually all around us. So before we get started into graphing anything, I just want to talk about one function first, and that is going to be our parent function. All right, and our parent function for a quadratic equation, for a quadratic function, is f of x is equal to x squared. Whenever we talk about our parent function, it is the most basic version of that graph or of that function, meaning nothing is being multiplied to it, nothing's being added or subtracted. It is just the basic of a quadratic. And we know anytime we have a power of 2 as our highest degree, or an x squared, and that's our highest degree, we know it is a quadratic function or a quadratic equation. So our parent function is just simply x squared. Nothing's being multiplied or added or subtracted. So we're going to talk about this one first before we get into anything else. All right, so here's our parent function. So if we were to graph f of x is equal to x squared, this is what our graph would look like. Now, there's a few things I want to talk about first on this graph before we go ahead and figure out how we can actually graph this. And the first point I want to talk about is this point here. If you notice, here is our parabola. It's our U-shaped graph. And here's where our graph stops and turns back around. So that point in red is called our vertex. And that vertex has two coordinates, an x and a y value. You might also see these coordinates written as k and h when we're dealing with our formula that we're going to learn later on. So you might see them written as k and h, but you can refer to them now as your x and y values. And each of these x and y values tell us something about our graph. So let's talk about these individually. First, let's talk about that y value. All right, so the y value of your vertex. This y value tells us our lowest or the highest point of our graph. So it tells us our max or our minimum value. Because if you see, here is the graph stops and turns back around. So at this point, our y value, according to our parent function, this will be the lowest point of our graph. Now, we know that our graphs don't always face up, as we talked about before. They can also face down. So when they face downward, here is where our graph stops and turns around. So here on this vertex, it would be our maximum or our highest value. All right, so it's important to know our vertex and what it tells us. So one thing that we can learn is it tells us our highest or lowest value, and that is our y value. All right, now the next thing that we're going to discuss is our x value. And we're going to talk about this one in blue. All right, and our x value, if you notice, here's our vertex. So if I draw a line, I'm going to draw a dotted line going through straight, it's supposed to be straight, a straight dotted line going through our vertex. So it's passing through our x value at this point. If you notice this graph, if we were to take this graph and fold it to the other side, it will match up perfectly. So that tells us that this graph is symmetrical. So our x value is our axis of symmetry. So our vertex will always tell us where our graph is symmetrical about. And when we start learning how to graph a few more times, or I'm sorry, not a few more times, but when we start to learn how to graph in multiple ways, one of the ways that you can use is finding your vertex and using that this vertex is our acts as a line of symmetry. So we can only plot points on one side and know exactly where the left side or the right-hand side are going to be. All right, so our vertex, there's two key and important things that you need to know. Our vertex is our turning point, so it's where our graph stops and turns around, like what it is here. And in that vertex, we have two coordinates. We have an x and a y value. Our y value tells us our lowest or a minimum value, or a highest or a maximum, depending if it's facing up or if it's facing down. And then our x value tells us our axis of symmetry. So it tells us where our graph is cut perfectly in the middle, where it is an identical image on both sides of that line. All right, now let's talk about how we can graph this. So for the first part, the first way we're going to learn is we're going to just create a table. And we're going to create a table with x and y. And we're going to be giving you your x values from the beginning. So for this one, I'm going to give you your x values of -2, -1, 0, 1, and 2. All right, the question we're going to do next, it's a little bit more than that, just a couple more values. But all you simply do is you're going to plug them into your equation. So our parent function is f of x is equal to x squared. So I'm going to plug in -2. So when I plug in -2, I'll do my work over here. -2 squared is equal to +4. So when x is equal to -2, y is equal to 4. So I can go 1, 2, 1, 2, 3, 4. So there's our point. X is equal to -2, y is equal to 4. Then I'm going to plug in -1. -1 squared, that is equal to +1. So we go to -1, up 1. So there's our point. When we plug in 0, 0 squared is equal to 0. So here we have 0, 0. If you notice, that is our vertex at this point. So our axis of symmetry is x is equal to 0. And our minimum value, because it's facing up, is y is equal to 0. All right, so that's something you'll have to be able to do for almost all your graphs. All right, now let's go ahead and do the next one. So when x is equal to 1, 1 squared is also equal to 1. So that's what we mean by it being symmetrical. So as we move equal points away from our vertex, we move 1 here and we go up 1. As we moved 1 to the right and 1 to the left, they had the exact same y value because they are symmetrical. So now when we plug in 2 squared, since we're moving 2 spaces from our vertex in this direction, the value 2 spaces away should be the exact same 4. Well, 2 squared is equal to 4. So we go 1, 2, 1, 2, 3, 4. So there is our point. And then once we plot our points, we can draw our line going through them, or our parabola going through them. All right, so that is a quick way of graphing. So we're just going to do one problem. That's it for this video. All right, so the only thing that we're going to work on in class that you're going to do individually is going to be graphing. And the only way that we're going to learn right now, the first method, is just going to be, we're going to give you the points. So we're going to graph this equation. Remember, if we want to denote it as a function, you should use proper notation. So f of x is equal to x squared plus 2x minus 3. But we're given this equation, and we're going to graph it using the creating a table from x is equal to -3 to +3. So -3, -2, -1, 0, 1, 2, 3. All right, then we're just going to plot these points in. All right, so now we're just going to go ahead and plug these points in and solve. So when x is equal to -3, y is equal to -3 squared plus 2 times -3 minus 3. Well, -3 squared is 9 minus 6 minus 3. So 9 minus 6 is 3. 3 minus 3 is 0. So our first point we're going to plot is at -3, 0. So 1, 2, 3, 0. All right, then our next point that we're going to plug in, y is equal to -2 squared plus 2 times -2 minus 3. Well, -2 squared is 4 minus 3, so this will then give me -3. So at -2, we're at 1, 2, 3, we're at -3. Our next point is going to be y is equal to -1 squared plus 2 times -1 minus 3. Well, -1 squared is 1 minus 2 minus 3, so that will give me -4. So -1, 1, 2, 3, 4. All right, our next point that we're going to plug in is y is equal to 0 squared plus 2 times 0 minus 3. So in this case, y is simply equal to -3. Sorry, I never plugged this one in. This will be -4. So here at 0, we're at -3. All right, so if you notice, here our graph is going down, or we have the left part of our U, and it's starting to go back up. So now I know that this point This -1, -4 is my vertex. And since I see that my graph is facing up, which we're going to talk about how we know before we even start graphing, just not right now, but as I see my graph is facing up, I know that this -4 will be my minimum value, and my axis of symmetry is -1. So you would write your minimum value, y is equal to -4, and then our axis of symmetry, x will be equal to -1. All right, now when we plug in this 1, we can say y is equal to 1 squared plus 2 times 1 minus 3. Well, this will then give me 1 plus 2 minus 3, which is equal to 0. So at 1, we are at 0. And if you notice, we're 2 spaces away to the left, we're at 0. 2 spaces away from our vertex to the right, we're at 0. Running out of space, so I'm just going to erase some of this. All right, so now we're going to go ahead and plug in 2. So y is equal to 2 squared plus 2 times 2 minus 3. So this will then give me 4 plus 4 minus 3, which is then equal to 5. So at 2, we're at 5. So 1, 2, 3, 4, 5. Right, and then this next point, I'm actually going to run out of space on this graph, but y is equal to 3 squared plus 2 times 3 minus 3. So this is going to give me 9 plus 6 minus 3. So 9 plus 6 is 15, minus 3 is 12. My graph only goes up to 10. So you would plot it. It would be somewhere up here. And after you plot your points, we're going to go ahead and draw our parabola going through our points. Right, and then just make sure you draw your arrow at the end, because that signifies that we are continuing, we're going to keep on going. So from here, we just won't cross that next x-axis, but we will draw our arrow going up. Now, if we wanted to plot even more points, we know that our next point is going to be here if we actually want to graph it. All right, that is it for this video. And remember, this section is going to be a few days, or we're going to cover a few days in class.